So thank you for being here. Now we want to really understand the concept of agonist drug, antagonist drug, full agonist, and partial agonist, which is also a partial antagonist. Now, what is the concept or the idea behind agonist drug? Now, this is a receptor. Okay, the blue structure here is a receptor. And I told you earlier that for a receptor, it should have at least two domains. You have two domains. So for every receptor, it should have a point or a place where a ligand will come and bind to. And it should have effector domain. So for a receptor, it should have a ligand binding domain and it should have an effector domain. This qualifies to be a receptor. And anything that binds to a receptor is called a ligand. So this relationship you're seeing here is a ligand. Why? Because it has a and a bind to the receptor. So it is called a ligand. So a ligand is anything that binds to a receptor. And a ligand can be anything, it can be drug, because drugs bind to receptors. So a drug is a ligand. Hormones can bind to receptors. Neurotransmitters can bind to receptors. Toxic substances as well can also bind to receptors. So once the ligand comes and binds to the receptor, it has actually got to the ligand binding domain. I told you that receptor should have a ligand binding domain. That means a point where ligand should come and bind to, and that is called a ligand binding domain. And for me to call something a receptor, apart from having the ligand binding domain, it should have an effector domain. It should have an effector domain. So here, the agonist drug comes here and binds to the receptor and fit. And once it has happened that way, we say affinity is present. So if a drug comes or any ligand comes and is able to bind to the receptor, that means there's affinity. So the propensity of a drug to bind to a receptor is called affinity. So here, this agonist or this drug just came in here and it has been bound to the receptor. So there is affinity. And here, when the drug was able to bind to the receptor, it was able to stimulate the effector domain. And this effector domain is going to release signals to the cell to cause the action that we need. The receptor should bind and stimulate the receptor. The ligand should bind to the receptor and stimulate effector domain and cause intrinsic activity. So when a drug is able to bind, that means having affinity, and able to stimulate the effector domain and cause intrinsic activity, that means there is efficacy. So if it is able to bind, there is that is called affinity. If the drug is able to bind as well and cause intrinsic activity to cause a change that we're looking for, that means that there is efficacy. So agonist drugs are able to bind to the receptor, meaning there is affinity, and it is also able to cause that kind of intrinsic activity. So there is efficacy. So agonist drugs are drugs that have affinity for the receptor and also there is efficacy. Agonist drug. Now let's go to the concept of antagonist drug. Now this drug, as I said here, the ligand comes in and binds to the receptor. So once that's able to bind to the receptor, oh, there is what? Affinity. Now, one thing about antagonist drug is that here they do not stimulate the effector domain here. So there is no intrinsic activity. It just binds. It doesn't cause anything to the cell. It doesn't change anything. So it only comes here and binds. But so far as it binds, then there is affinity. but because it cannot release any signal to the cell to cause the thing to cause intrinsic activity, we say there is no efficacy. So for agonist drug, there is affinity as well as efficacy. It is able to bind as well as cause intrinsic activity. Antagonist drug, there is affinity because it can bind, but it's not able to cause any intrinsic activity, any biological action. So there is so efficacy is absent. Now, the concept of full agonist. Suppose that this is one receptor and this is one ligand. Now, when the ligand comes, it is able to bind to both sides of the receptors, So definitely there is affinity present. But one thing is that both of the receptor sites here, they are all having effector domain to cause the intrinsic activity. They're having the effector domain to cause that kind of intrinsic activity. So here, they bind to the receptor, so of course there's affinity. And because they're able to stimulate both sides of the receptor, we see there's efficacy. But this efficacy is maximal. For full agonist, there is affinity and there is a maximum effect, the maximum efficacy. That is full agonist. Affinity is there and able to stimulate both sides of the same receptor. So there's going to be here, intrinsic activity will be here, intrinsic activity will be here. So there will be a full maximum effect that is efficacy. Now the concept of partial agonist or partial antagonist. Supposing again that these are one receptor, these are the same receptors, and this is the ligand, the drug that comes. Now the drug comes here and fits into the receptor. So here there's affinity because the drug is able to bind the receptor. So there is affinity. But one thing is that here the drug is only stimulating one side of the receptor, the effector domain. The drug is stimulating only one side of the effector domain to cause intrinsic activity. One side is not causing any intrinsic activity. So there will be minimal efficacy because of this one side. So there will be minimal efficacy. So here it will cause intrinsic activity, and here no intrinsic activity will be caused. So fine, there are affinity present, but the efficacy is minimal. So I'll say it is a partial agonist. I can also say this is a partial antagonist, but the antagonist side is also partial. It is not stimulating. I can say partial antagonist, or I can say partial agonist because one side is not stimulating. Overview. Agonist drugs have affinity and cause intrinsic activity and cause an action. So there's affinity and its efficacy. Antagonist drug is able to bind its affinity, but is not able to cause any intrinsic activity because it's absent. Full agonist. The drug comes here and binds to both sides of the receptors, so there's affinity, and stimulate both sides of the receptors. Cause maximum efficacy and maximum intrinsic activity. That's a full agonist. Partial agonist. The drug comes here, binds to the ligand bind domains of the receptor, but it's only able to stimulate half side of the receptor. So when that happens, I'll get the effect, but it is too small. Both sides are not stimulated. So there's a minimal efficacy. So because the one side is being stimulated, I can say this is a partial agonist. It is not yet a full agonist. It's a partial agonist. And this side is not able to cause any intrinsic activity. But so this one is also free. I can also say partial antagonist. Partial agonist is same thing as partial antagonist. Thank you.